Greetings. Welcome to another video in my series on the Racket programming language. Today we're going to look at another use of the binary basic tree structure that we developed. To give you a review, we basically developed this file to define what a tree is, and this is of course a binary tree in the fact that basically every tree either is a leaf or it has two branches that are also trees. So I've gone in and loaded this into the environment, and I've defined this sample tree as this following list. And the interesting thing about this list, and it's not a coincidence, is this looks exactly like a scheme expression to do a bunch of operations and return a number. And I'm going to ask myself, well, is this a tree? So I'm going to go ahead and run this. And sure enough, it is indeed a tree, and it should be fairly obvious that that is why it's the case. We have the trunk starts here, we have this basic value here, and we have a tree on the left, and we have a tree on the right, and then we have yes. And so we go ahead, recursively look through it. This is very obviously a tree. So what if I want to iterate over this tree in such a fashion that it actually executes it as if it was a Racket program? And that's what I've done here. And this has the basic structure. Of course, if this tree is empty, I'm just going to return this empty list. If the tree is a leaf, I'm just going to return the value of that. And the leaf should be a number, so that should work. Else, I'm going to define, this is a new thing that is new to you. If you haven't done any more experience with Racket, this is a let. This is a way of introducing local values into a part of the program. So we are introducing a left tree, val, and right tree, which have the values of these that are returned from these function calls here, and just makes it easier so that we don't have to call these multiple times. And then what I've done is I also have another form that we're using here, which is called case. And what this does is this takes a look at the value, and if the value matches the thing on the left here, it will return the value on the right. Okay, I've done that for plus, minus, star, and so on. And if I don't see one of those four things, I don't know how to compute it, so I'm just going to say this is an invalid tree and end. So now what I can do is I can see if calculate tree works, and indeed it does. Now, going back to, well, why don't we just use expressions like this? Right? And I'm just going to put this as a string here, so Racket does not complain about it trying to be a program. But here's the thing, as I noted out before, this has a lot of ambiguity in it that us humans have rules to deal with. We know that we do division and then we do multiply, but if there's a parentheses, we always do what is in the parentheses. So we know about the order of operations and how to do them. But there's also other little things too. We could have things like this, right? What does that mean? Right? Is that a typo? Or do they really mean minus 3? Should I allow this? And so there's all this ambiguity here. Even in the simplest type of calculation expressions that any program we would obviously want it to be able to do, taking them as a string like this and parsing them is actually incredibly complicated. So much so that there's an entire set of computer science that is organized around the notion of defining grammars that allow basically someone to scan or lex. So basically, I'll put in a comment block here. So basically, there's a whole set of stuff that defines grammars and tools that basically scan input, turning it into tokens. This seems like, oh, that's fairly easy, but you'd be surprised. Basically, it's one of those things where it's like, okay, alrighty, what's a number look like? If there's a space there, is that legal? Do I have to have the 0 there or not? Right? If there's a plus there, is that okay, or do we just allow that? Right? Oh, wait a minute. We have another dot. That's not a legal number at all. Or is it? Did they mean 0.2 and then a space 3.4 and we don't have an operation there? So even scanning the input to get what the tokens are can be rather difficult. For those of you that are more advanced programmers, you may know that basically what happens is you use a kind of regular expression to match parts of that string. And then we have the grammar itself. And what that does is that it takes a stream of tokens and rules and eventually turns that into a syntax tree or the data structure, or basically a set of errors why it couldn't parse that. It could not parse that file that you gave it. And there are a number of ways to do this. It's just massive. There's a whole family of algorithms for how you do one way of parsing a string. There's another one that uses a completely different set of parsing things. There are also just manual parsers that use a combination of all sorts of crazy stuff to handle types of things. There's a lot of very complicated optimization that goes around this to make sure that these run well. And not only that, but there's a lot of features in how you define these things such that you can deal with ambiguity that shows up even in the simplest types of things. Another example is the following. If you're familiar with other programming languages, the statements like this happen all the time, right? But the problem is that this is completely ambiguous. There's two ways to read this. If we have this following here, right? So basically we have two types of things. We have this here. We can either say x equals 9, then this whole thing, right? Only if x equals 9, then try to do the rest of this, right? Or we have another way of thinking about if x equals 9, then only do this part, and this is the else for this first if, right? This is, again, a completely ambiguous statement. Now, we as humans have, again, rules and heuristics that kind of make sense of this type of stuff. We look at clues like indentation, white space. Not only that, but we tend to group things together. So we would tend to think that, oh, this if then else tends to stick together. It wants to be closer here. And even the tools that I talked about do this, have a notion of saying, oh yes, by the way, when you have this else here, bind it to this closer if, not to this outside one. But this is like basically fundamental programming syntax. Given all this and given all this complexity, this is where Racket becomes very useful, is that if I want to do stuff like reason and talk about programs, I don't have to worry about all the hassles in parsing because I already have this fundamental structure that is I know how to treat it as a programming language. Racket does this for me. And two, is super easy to parse because Racket has just very obviously a lot of built-in capabilities for taking a file that has a bunch of X expressions in them and turning them into the actual X expressions. So I don't have to write a parser or a lexer for all this stuff. That is incredibly useful. And this is why I think Racket is fundamentally important for programmers to use, is that it keeps you from getting tripped up on the surface syntax and allows you to understand the more fundamental concepts that go into a programming language. instead of just seeing the surface, we can see, oh, this is a function. This is a local variable. This is how scopes work. This is how capturing scopes works. This is why function scope versus lexical scopes. All these things that you'll hear senior programmers bounce around and talk about, all that kind of stuff, it becomes a lot easier to deal with. Because what we can do is a lot easier to write programs that reason about simple Racket programs than in any other language, period. There's just no question about that. Not only that, but it's made easier to write programs that create programs, because all you're doing is that you just have to write out a list. We know how to construct lists in Racket. It's very easy to do. This has some practical implications. First of all, in a lot of newer programming courses or degree tracks, compilers and all these types of things is optional. Sometimes it's an optional senior elective. Sometimes it's even, graduate preferred. And when I started, compilers was a required class. I could not even get a degree without doing a compilers class, in which one of the things we talked about is how to actually define these grammars and these scanning this input to do this. We learned how to use two tools that are called Bison, Flex and Bison, which are newer versions of Lex and Yak. And these are tools that, existed before Linux did. They were way back in the Unix days. And they implemented some fundamental ideas or fundamental algorithms. And ultimately what it was is you gave them some specialized input, and they would create a highly optimized C file for you to go ahead and parse in a file or a string. So that was required. Well, as times changed and things got more complicated and what programmers needed to do got more, basically a lot more complicated and stuff like that, the requirement to take compilers and stuff like that went to the wayside. There's only so much you could do. You can't have, students going to college for 6+ years just to get a bachelor's degree. Something has to give. And not only that, there's a huge demand for more practical types of stuff. And certainly the idea of, a student coming in and saying, I'm never going to write a compiler, that is a completely valid statement, because yes, only a very, very small percentage of people would work in this environment. And those that do probably all now have graduate degrees or just lots of experience and were able to gain that in the industry. So why should I learn about this type of stuff given all this and stuff like that? And why shouldn't I just use one programming language? Well, as you know, programming languages change and evolve, and what people used to use, people don't use anymore. The first programming languages I used still exist, but no one would ever use them. I started out doing a BASIC on Atari 400. The next language I learned after that was a variation of BASIC that was closer to what you would know as a Visual Basic, more structured. Then I learned Pascal in high school. Then I had learned C. Then I learned Java, then C++. When I got my master's, I went off and then I learned C#, as well as learning F#. Then I went back and then I learned a bunch of other languages like ML. And now I'm learning things about Elixir, Erlang, and others. And even I'm getting more into Haskell even though I learned F# back in the day. So languages change, the frameworks change. Not only that, but if you want to grow as a programmer and do different types of things, you're going to have to confront different environments. Despite the best efforts of a lot of people, you can't really use TypeScript for everything. And so at some point you might want to switch and do something different that uses different languages. You might end up in your career saying, there's this really good opportunity for me to do stuff in AI. And also now I'm in Python and C++ land. Or a lot of people will look at things like, oh my gosh, I'm never going to get a career. And they only look at front end development. And they look and they never look at it and say, it's like, oh wow, if I learn C and learn how to do it in embedded programming, that's really great. So I can learn more about that. So without the ability to learn new languages and these fundamental language concepts, you really are limiting yourself to how you're going to grow as a programmer. A practical example of this is that when I was working at a consulting firm after I got my PhD, they were calling for someone who was a Python programmer, and it was a short-term opportunity, but they were, wanted to make sure that someone got it, and I was, basically in between projects. And I said, okay, you know what I'll do? I'll take a look at this And if you need somebody who's a really fancy, experienced Python programmer, I'll let you know, and we'll try to get somebody in on that. But we'll see how far it goes. And I did this despite never having programmed in Python for any serious amount. And the reason I did it is that I knew, well, most of the time, the problems that arise are not about the language, but about the domain and what they're trying to do. And two, I knew enough about programming languages that given a good IDE, in this case PyCharm for JetBrains, a bit of references online, I can start programming in Python right away. And I should probably be able to do all the things I need to do in Python in a fairly reasonable amount of time. Within basically a week or two, I should be able to do all the things that I need to do for this project. And if not, then yes, I do need to get someone who's more experienced in Python. And sure enough, that's exactly what happened. This was not a massive Python type of thing. They just needed someone to bring in these extra scripts into this environment, and they were fairly straightforward. You know, the person I was working with was really on top of it, just needed someone to do some coding for him. That was pretty simple. Got PyCharm, saved up some files, did some testing. That contract ended on time, and I even got a little bonus for taking it on. And so what learning all this did for me, which is I had to learn, back then Racket didn't exist as Racket, it was at Scheme, but I had to learn all this stuff and then program it in this environment. And what that did is, I found that I really enjoy learning and doing stuff about programming languages as well as software engineering, but I also found kind of the Rosetta Stone that allowed me to learn new languages very quickly and to bring in new frameworks fairly quickly because I was understanding what was going on. And that's why I think if you stick to this and do a lot of programming with interesting examples and getting really into it, you will find yourself able to understand at a more fundamental level what a programming language is and what code really represents and how it ultimately is turned into stuff that's run and executable. Anyway, thanks for watching. Look forward to seeing you in the next video.